My name is Rajiv Thakur. I'm a director for marketing and business development at Silana Semiconductor, and I'm here with my colleague Ehsan Zaman. And we are basically wanted to provide a short preview, essentially to showcase the products that Silana is developing to address the pain points we see in the LiDAR industry and in the rangefinder industry. As a short introduction to myself, I've been in the LiDAR industry for about 10 years right now. I worked for Velodyne LiDAR in Austria for 4 years and 1 year with AVA. Before that, I was with Osram for about 5 years, selling lasers and APDs to many LiDAR customers. And I'm also an SAE instructor for LiDAR and infrared camera. I'll ask my colleague Zeman to introduce himself also, please.
Thanks, Rajiv. Hello, everyone. My name is Ahsan Zaman. I'm a director of product marketing for firepower laser driver products at Silana Semiconductor. I have been working with Silana Semiconductor for about 7 years now, and I have been working in the semiconductor and IC design experience industry for about a decade. My background is in electrical engineering. I have a PhD in power electronics from University of Toronto. So could you please first give us an overview of what are the key pain points in the LiDAR industry in today's market?
Thank you, Hassan. Yeah, so essentially LiDAR, as you know, has been developing for nearly 7 to 10 years now, and it is becoming quite mature, especially time-of-flight LiDAR. The biggest problem LiDAR is facing for scaling and really increasing the volume is bringing the cost down. The automotive market essentially wants the price ideally to come well below 300, ideally about $100 or so, which is kind of where the radar and camera are. And essentially, so bringing the price down is the number one for it. At the same time, they're looking to improve the performance, being able to see further and being able to see smaller, darker objects, so that we can use them for self-driving, ADAS, and other applications. So they essentially, and to be able to increase this range and see these dark objects, you need to increase the peak power of the laser to be able to get a better signal to noise ratio. And for reducing the cost also, you need to be going to better architectures than using single lasers. You want to be going towards arrays and something like that. And essentially, this is kind of where some of the pain points that Silana is doing is coming into it for developing the technology.
Okay, thanks, Rajiv. And now we can talk a little bit about the Silana firepower family, since you have already indicated Silana is working on that area. So could you please give us an overview of what Silana laser fire solutions are currently being developed for the LiDAR market?
Thank you, Hassan. So the first product is called SL2001. And essentially, this is an integrated ASIC which does the boosting of the power. We take an input voltage and bring it up to a higher voltage to be able to fire the laser. And then we also control the firing of the laser. The key thing about this particular product is that we're able to fire up to 1 kilowatt in under 3 nanosecond pulse width. And this is a very industry-leading performance. And we are heading towards going down to even like less than 1 nanosecond and being roughly about 250 watts of peak power also. So we're really cutting the edge there. And what this allows us to do is essentially, as I said, the higher peak power allows you to get a better range and get a better signal to noise ratio. And also we're able to reduce the BOM cost because the content which is needed for firing these lasers is now smaller and we are more efficient, so it reduces the heat. So lots of benefits with this product for firing lasers.
Okay, that's great to hear. And how about the arrays? Because most teams are now moving towards multi-channel architectures. So could you please give us what Silana is doing for those array type solutions?
Yeah, thank you, Hassan. So as you know, LiDAR, you have multiple lasers, and currently, single lasers are aligned to the APDs that are fired. But to reduce the cost, you need to have an array of lasers which are basically coming off the same substrate on the same die. And when you have an array of lasers, firing these lasers becomes more complicated because you want to be able to fire them without affecting the performance of the adjacent laser or having a leakage or light coming out from the adjacent laser. And this is not easy to do, especially when you have a whole bunch of lasers, going up to 56 or 128 or whatever on that side. And this is where Silana comes in, that we have some very unique solutions which allow you to fire both VCSEL arrays and edge emitting laser arrays in a very cost-effective, efficient manner, and making it a very compact size and reducing the cost. We are able to reduce the cost down roughly about 35% and bring the footprint of the PCB down by roughly 75%, which is amazing, which is exactly what the LiDAR industry wants to do. So very exciting times, and we're looking to see how we can engage more customers and bring this benefit to the LiDAR industry. Very good, Hassan. Could you elaborate a little bit regarding how we are enabling our customers to evaluate and incorporate our product into their designs?
Yes, so we have all the standard marketing collateral documents readily available for our customers. If someone wants to look at, for example, the datasheet, app notes, evaluation boards are all in place. And also we are providing simulation models for various available lasers as well as performing system level solutions for them. And we have an expert team of application engineers who can provide customers with their specific need and meeting their specific specs. And in addition to that, we are also available to provide any system level optimization as well as layout and schematic review in the various steps of the product development of the customer.